Now we're going to look at solving systems of equations using the elimination method. And the two special cases that we're going to look at are when you have a system that is inconsistent, and then the other one where the system is consistent and dependent. Okay, so for my first example, I have x minus 2y is equal to 5, and the other equation is 4x minus 8y is equal to 3. Remember to make sure that your equations are lined up so they look like this. Ax plus by is equal to c. Okay, my x's are lined up, my y's are lined up, and my constants are lined up. Now I'm going to look at the coefficients for my x terms. It's 1 and 4 here, and negative 2 and negative 8 here. I think what I want to do is get rid of the x term, so I'm going to multiply this first equation by negative 4, and the reason I chose negative 4 is because negative 4 times x is negative 4x. If I add that to positive 4x, that will cancel. So when I distribute this negative 4 times x is negative 4x. Negative 4 times negative 2y is positive 8y. And then negative 4 times 5 is negative 20. And then I'm just going to rewrite the second equation, 4x minus 8y is equal to 3. Remember, my goal was to get rid of the x term, so I'm going to add these two equations together. Negative 4x and positive 4x cancel. Negative 8y plus positive 8y plus negative 8y is 0. And negative 20 plus 3 is negative 17. Whenever you end up with a statement that is not true and there is no variable, this is no solution. There is no solution to this system. So what that means is if you were asked to classify this, this would be inconsistent. And to tie this back into when we were solving the systems by graphing, if you were to graph these two lines, you would find that they would have the same slope and they were parallel. They never intersect, so your answer is no solution. My second example is 9x minus 3y is equal to 6 and 3x minus y is equal to 2. They're lined up perfectly, so I don't have to do any work there. I look at my coefficients. I have a 9 here and a 3 here, and if I want to get rid of the x terms, I can multiply the second equation by negative 3. If I rewrite the first equation, I'll have 9x minus 3y is equal to 6. And then when I multiply the bottom equation by negative 3, I get negative 9x plus 3y is equal to negative 6. When I add these two equations together, 9x minus 9x cancels, negative 3y plus 3y cancels, so I'm left with 0 on the left side, and 6 plus negative 6 is 0. This equation is always true. 0 is always equal to 0. So whenever you get a statement that's an identity, it's always true, that means that these two lines are exactly the same. If you graph them, they would be right on top of each other. So your answer here is this would have an infinite number of solutions. Infinite number of solutions. And if you were asked to classify this one, it would be consistent because it has at least one solution. And it would be dependent because it has an infinite number of solutions.